Hello children, I am Sudesh sir from Sudesh Coaching Classes.
Welcome students to Arithmetic Progression, Season 10, Episode 4, Part A. Today we are going to learn what is a sequence. Now, this sequence is a set of numbers arranged in a definite order. For example, n is equal to 1, 2, 3, 4, 5, 6, or w is equal to 0, 1, 2, 3, 4, or x is equal to 2, 4, 6, 8, 10. So there are variety of sequences. Okay, let's take an example of one. So what is an arithmetic progression? It is a sequence whose difference between two consecutive terms is always constant. Example 2, 4, 6, 8, 10 and 12. Here the difference between the every two terms is always 2. You can see that very well. Okay. And therefore we can say the difference 2 is constant. Right? So it proves that it is an arithmetic progression. Here the first term is 2 and denoted by letter A, and the common difference is 2 and denoted by letter D. So let's find the first term, find A and D for the following arithmetic progression: 127, 132 and 137, etc. Here the first term is 127. The second term T2 is 132. The third term is 137. So difference D is T2 minus T1, which is equal to 132 minus 127, which is equal to 5. Again D is equal to T3 minus T2, which is equal to 137 minus 132, which is again equal to 5. So D is equal to 5. We can say it is constant. So A is 127 and D is equal to 5. Let's take another example. 5, 1, minus 3 and minus 7. Here T1 is 5, T2 is 1, T3 is minus 3 and T4 is minus 7. What is A? It is 5. Let's find common difference. D is equal to T2 minus T1, which is equal to 1 minus 5, which is equal to minus 4. D is equal to T3 minus T2 is equal to minus 3 minus 1, again it's minus 4. D is T4 minus T3, which is equal to minus 7 minus of minus 3. So it will become minus 7 plus 3, which is equal to again minus 4. So D is equal to minus 4, which is constant. So you children can find A and D for the following AP by pausing the screen and going for the sums. Now let's find an AP whose A and D are given. A is 10 and D is 5. Let's find it out. The first term A is T1, which is 10. T2 is equal to T1 plus D, which is equal to 10 plus 5, which will give 15. D3 is equal to T2 plus T, which is equal to 15 plus 5, which will give 20. The AP is the first term 10, 15, 20 and so on. Right? Did you understand? Let's go for another example. A is 6 and D is minus 3. Okay? Let's find the AP. Our first term over here is A is equal to T1, which is equal to 6. What is T2 then? T2 is T1 plus D. Remember the formula, which is equal to 6 minus 3, which will give 3. T3 is equal to T2 plus D, which will give us 3 minus 3, which will give 0. T4 is T3 plus D, which will give 0 minus 3 and which will give minus 3. So the required arithmetic progression is first term is 6, 3, 0, minus 3 and so on. Find the arithmetic progression for the following sums by pausing the screen and doing the sums. If the first term is T1, the second term is T2, the third term is T3, so the nth term will be Tn. Did you understand? Right. So the general formula for finding Tn is equal to A plus n minus 1 into D. For an arithmetic progression 12, 16, 20, 24, find the 24th term. Let's find it out. For here the first term T1, which is equal to 12, T2 is 16, T3 is 20, T4 is 24. Let's find D, which is equal to T2 minus T1, which gives 16 minus 12, and that will give us 4. So we have A, we have D. Let's find Tn is equal to A plus n minus 1 into D. Substituting the values, T24 is 12 plus 24 minus 1 into 4, which will give 24 minus 1 will give us 23, right? And 23 into 4 will give us 92. This 92 plus 12 will give us 104. So the 24th term is 104. How many 3-digit natural numbers are divisible by 5? Let's find it out. The 3-digit numbers start from 100 and end at 999, right? Okay. Now, so required terms which are divisible by 5 should be start from 100 and end at 995. So our first number will be 100 and the last number will be 995. And our arithmetic progression will be as follows: 100, 105, 110, 115 and the last number 995. Using the general formula Tn is equal to A plus n minus 1 into D, substituting 995 is equal to 100 plus n minus 1 into 5. 995 minus 100 and the rest is so on. 995 minus 100 will give us 895, while multiply by 5 goes over there, becomes divided by 5, which will give us 179 is equal to n minus 1. The minus 1 goes over there, becomes plus 1. 179 plus 1 will give us 180. So there are 180 terms. The sum of the first n terms in the arithmetic progression is given by the formula Sn is equal to n upon 2 T1 plus Tn. Or Sn is equal to n upon 2 2a plus n minus 1 into D. Find S27 for A6 and D equal to 3. Let's use the formula Sn is equal to n upon 2 2a plus n minus 1 into D. Substituting the S27 is equal to 27 upon 2, 2 into 6 plus 27 minus 1 into 3. First we'll multiply 2, 6, that is 12, and 27 minus 1 will give us 26. Let's now multiply 26 into 3, which will give us 78, or 78 plus 12 will give us 90. I'll multiply 90 with 27 to give us 2430, then dividing by 2 will give us 1215. Let's find the sum of first 123 even natural numbers. The sequence will be 2, 4, 6, 8, 10 and so on. So the first term A is equal to T1 is equal to 2, T2 is 4, T3 is 6, T4 is 8, T5 is 10. So D is T2 minus T1, which is 4 minus 2, which will give us 2. Again D is equal to T3 minus T2, which is equal to 6 minus 4, which will give us 2. Again D is T4 minus T3, which will give us 8 minus 6, again the 2. So if we find D is equal to 2 is equal to constant, so it is an arithmetic progression, right? So we can use the formula for arithmetic progression. Sn is equal to n upon 2 2a plus n minus 1 into D. S123 is 123 upon 2 bracket 2 into 2 plus 123 minus 1 into 2. Find 2 into 2 will give us 4, while 123 minus 1 will give us 122. Now let's multiply 122 into 2 and that will give us 244. Let's now add 244 plus 4 and that will give us 248. Let's divide 248 by 2 and that will give us, it will give us 124. Now let's multiply 123 into 124 and the final answer will be 15252. So this is the whole sum, children. You can see the whole page. Now that's all folks for today. Let's meet in the next lecture with the more sums and more of arithmetic progression.
Hello children, I am Sudesh sir from Sudesh Coaching Classes.